Hello, everyone. I hope you can hear me. Okay. So, today I wanted to talk about Moire. I'm not 100% sure how to say it. I think it's Moire Patterns. So, Moire Patterns are these patterns that you see often when two patterns that look very similar are overlaid on top of each other. So Wikipedia has a pretty good article on Moire patterns. So for example, here are sort of two sheets. Let me zoom in here. Kind of that are on top of each other, and you can see they both consist of kind of parallel lines. And then the parallel lines, you get one set of parallel lines. If you move them, you get this kind of like artificial pattern. Like your brain can't help but see something going on here that perhaps isn't actually going on here. So it doesn't have to, you don't have to have motion to have a moire pattern. So for example, this is another example. Like if you take sort of two crosshatch type patterns and overlay them on top of each other, then you get this pattern underneath. It looks like you have kind of a polka dot grid of kind of circles and dark spaces. And so I've always been kind of fascinated by these patterns, and I wanted to do something with them. And so I was interested in, actually some of these are pretty good if you look. And so as you can see here, these patterns arise when you take two kind of similar patterns and you just kind of overlay them on top of each other, but you slightly offset one in some way. Maybe it can be a translation that's offsetting one of them. Maybe it can be kind of a slight rotation that's offsetting one of them. All of these things produce really interesting effects. This is good actually because it's a spiral. So you can see here, in this case, you have one. So here for both of these, you have kind of not spirals, but sort of lines emerging from a center, and the two centers are slightly off from each other, and one is rotating clockwise, one is rotating counterclockwise. Like I said, you don't have to have motion necessarily to see these patterns. You can imagine if this was even holding still, you would see these patterns, these sort of circles that are kind of appearing. It looks kind of like one of those charge diagrams that you see in physics all the time. And so, like I said, these are very interesting. And so I kind of wanted to examine them, do something interesting with these patterns if possible. And so the question is how to do this. And so my idea was to kind of insert these patterns into random kind of images. So as you can see, any image that consists that's made of lines close together, you will see these effects. And so generally, if you're an artist, you're a photographer, these are things that you, like moire patterns are things that you probably want to avoid happening in your pictures and in your paintings and so on. And the reason for this is that they give you the impression of something being there that's perhaps not necessarily there. So you can see here in the background of this image, the sky was meant to be maybe a bit more flat. It's unclear whether the artist intended this kind of murky, splotchy appearance in the sky in the background. So generally you want to avoid these effects unless, of course it's completely intentional, because they give the appearance of things that are not there. This is another pretty good video of the effect you can see. So there's like a netting in front of a billboard, and so you can see like this the picture of the model is kind of obscured by these grayish, whitish patterns that appear in front of it. In any case, my idea was to kind of incorporate these patterns into images, and I was trying to think of what to do with this. Actually, before I dive into the image stuff, one potential application, or not potential, like one application of these patterns that I found out about as I was looking up stuff for this stream is there's this thing called the Imagon light. This was in a Tom Scott video. Maybe I'll link to the video in the description. So Inogon, sorry, not Imagon light. So here's the Tom Scott video. Here, let me. Why don't I just show it to you? So
It's difficult.
So in this video, the Moire effect is used. Well, not in this video. In this light, the Moire effect is used in this very interesting way, where if you're a ship and you're coming in from one side, then it looks like the arrow will point you in the correct direction. So if you look at this thing from kind of the right, it'll tell you to go left. But if you look at this thing from the left, it'll tell you to go right. So let me find the actual animation of it doing it in this video. Man. Okay. I'm not really finding it in this video, though I did want to credit where I found this particular type of light. I'll show you what I mean. So I made a little animation type thing of this exact light. So this isn't exactly right. They obviously put more effort into it. So you can create the effect by just taking like two sets of lines. So this is two sets of lines in 3D space. Please let me know if you can see this reasonably well. Let me make this a little bit bigger so that it's relatively clear. Okay. So if you're dead on, it looks like there's a vertical line, or so this is what this like set of X's look like. So you can see there's this Moire pattern that's like very clearly emerging that has like a plus in the middle of it. And once again, this isn't exactly the pattern that's used in that light. They obviously spent way more time on it than I have, but you can see where the Moire effect would be useful. But for example, if you look at this light from the like from the right, like if you're kind of tilted this way, it kind of looks like arrows pointing you left. And if you look at it from the left, it kind of looks like arrows pointing you right. And so you can actually use these in the naval navigation. So if there's like a ship out at sea or whatever, this you can put these like lines, or you can put like a grid in front of the light. And with no mechanical effort or anything, like with no tracking or whatever, this light will point you in the direction that you need to go, so that you're always moving towards it. And there's nothing like mechanical here. You're just taking advantage of the Moiré effect. And I thought that was really cool. And so this is my attempt to recreate it, though the people who patented this obviously did a much better job. And in their simulations, it really does look like arrows. So I do want to find a good picture of it. Let's see here. So yeah, so this is what theirs looks like. So if you look at this type of light dead on, it's like two vertical bars. But if you look at it from the left, it kind of looks like arrows pointing to the right. And if you look at it from the right, it kind of looks like arrows pointing to the left. So magically, it tells you exactly the direction that you need to travel, which I thought was really cool. Anyways, so that's just one application of these ideas. Of course, there are many. Though usually, like I said, if you're a photographer or if you're an artist or something like that, these patterns are usually something you want to avoid, because they'll put things in your art that you may not have intended to be there. Although, if you're like a happy little accidents Bob Ross kind of artist, maybe that's not too big of a deal for you. Regardless, one thing that I realized was that an interesting way to insert these patterns into artwork or images would be to kind of replicate the way the printing on money is done. Because if you look at the way faces are printed on money, you will notice moire effects there. So that type of artistry is called a steel engraving. Let me just... So steel engraving, hopefully, yeah. So steel engraving is, I guess you take like a steel sheet with a pattern engraved in it, and you just like stamp it on something over and over again. This is clearly how they print money. And so it has a very peculiar and particular effect on artwork. You can see it here. And it has a kind of a visual aesthetic. It has kind of an interesting appearance. And as you can see, it does produce these effects. So my next goal was to try and recreate an image using kind of this steel engraving kind of pattern so that it would have an effect that could produce a Moire effect. So that's the first project that I engaged in. That was like the first idea that I came up with, is to kind of like recreate this effect for an arbitrary image programmatically, so that an arbitrary image would have this Moire effect. And so here's what I came up with. I'll show you the end result first. So for example, this is a picture of my cat, one of my cats that I've been using in my videos. So here he is. It's a 900 by 900 image, and if you just hit enter, the computer processes for a couple of seconds, whatever. It's just doing its thing. And yeah, this is, I kind of wanted to make animations with like moving things, but the problem is, so there you go. So this is, this picture of my cat converted into this pattern. I don't quite see any Moire effects here just yet. I do love this picture of my cat, but it's cool. It's like just with a couple of lines of code, though granted, these couple of lines of code were really annoying to write and to get all of the parameters pinned down. This took me a little bit of time, unfortunately, but as you can see, you can convert an image with not too much effort into this kind of crosshatch steel engraving pattern. Are the dark areas in the image just dense lines? Yeah, pretty much. Though you can use whatever function you want. So I use sine. I use sine waves. So here, let me split this image up to show you what's going on. You do need to. So I had to fiddle around with this a lot in order to get it to look right. So I'll tell you what I did exactly to get this to look right. So absolutely, the denser parts of the image are just lines that are somehow closer together. So here's the idea fundamentally. So you just take a bunch of sine waves. And by the way, you can use whatever function you want here. I just picked sine waves because that's kind of like what the engraving on money looks like. And you just take a bunch of them like really close together, right? So you imagine you just like fill the page with these. Okay, so now that you have these, basically what you do is you apply this pattern to the dark regions of your image. So for example, you have your image, right? And so in this case, it's a picture of a cat. Kind of looks like Batman. Hold on, I can do this. Beautiful. Okay, no. It's a very mischievous looking cat. Okay, beautiful stuff. So what you do is you apply these sine waves to the picture of the cat. But the question is, where do they go? So the other trick that I used is I binarized the image at a threshold. So an image, if you take a grayscale image, it's just values on a gradient where on one end is black and the other end is white, and you just increase the brightness as you go. Usually these values are denoted from like 0 to 256. In Mathematica, they're from 0 to 1. And so when you binarize an image, you're just converting it to a strictly black and white image. So you want there to be no gray elements here. And so the question then becomes, where do you put the threshold? See, that becomes the question. So where do you put the threshold? So the threshold is the point beyond which all the grays become white, and below that all the grays become black, essentially. So hopefully that makes sense. And so the idea is different width sine curves are applied to different binarized versions of the image, and then you add them up. You like superimpose all of them, and that gives you this effect. Let me show you a couple of them, just so you can see what I'm talking about. So for example, Let's just kind of 6 of these. I don't want that. So I have this. I'm going to get rid of the R. Leave it at 0.001. Get rid of this. So I'm just, of course, hopefully this will work. Okay, yeah. So this is, for example, one of the images, right? That are all like superimposed to get this. And so what I'm doing is I'm taking a grayscale version of the image and I'm binarizing it, right? So what this is telling me is that, you know, the whites are like, so this is set at a very, very high threshold, okay? So this is set at a very, very high threshold. So anything that isn't extremely bright will become black. So the image is binarized at a very high threshold. So anything that isn't like pure pristine white will become black. And then the sine waves are kind of inserted in the black regions of this image. So the black region of this image is replaced with a sine wave. Okay. And then what you do is you drop the threshold a bit. Okay. So now you're seeing more details, essentially, right? So because I dropped the threshold, the parts of this image that are, and thank you, the parts of this image that are like solid black must be slightly darker than the ones before. So to that one, so for example, if you put like 0.7, and so for this one, all I did is I upped the thickness of the sine waves that I was using in that image. So as you can see here, and then you just do it over and over again, and you just superimpose all of the images, and that's essentially how I was able to get the Moire effect in my images. Well, okay, that's how I was able to get kind of like that money look to the images, and so this is, for example, the final result. One thing is really interesting is you can like not so what I did is I rotated the sine waves as I went, and that produced this picture, but you don't have to rotate them. So let me get rid of the rotation here and see what that looks like. And I actually think it produces a really interesting effect as well. So, sorry, it takes its sweet time. So I really wanted to do like video animations with this, but because it takes so long to produce a frame, I think this is my fault. I should have done this in like Python or something. The Mathematica is a little slow with this kind of stuff. So this is what it looks like if your sine waves are all the same sine wave, essentially. So you get like, it just looks like an image, basically. And sometimes you see people do art like this too, like online. Sometimes you'll see very, very popular images, like someone is drawing with a pen, and then they, you know, they hold and hello Prasad. And so they'll like hold their pen down a little bit harder at some parts, and some people are so amazingly talented they're able to do it without picking up their pen off of the paper. I don't know if you guys have seen any of these or if you know what the heck I'm talking about. So, you know, people who can like draw an image in like one go by just they're just drawing like one line, but they press their pen down a little harder, so that becomes the darker parts of the image, and people are able to do this in their head, which is kind of insane. So there's that. And you can mess around with a lot of things. So for example, I'm going to add the rotation back in. So just add the rotation back in. But you can like bump up the amplitude of the... You like this version better? All right, fair enough. So this version is nice, but you're never going to see, and hello, Ken. Yeah, it might be a lot faster to kind of store. I agree with you. Lost Genta, I should have stored everything in memory. But this is, I have to say, this is all very hacky and slapdash. So you'll have to forgive me for my bad programming. But no, you're absolutely right. I should have. So every time I run this code, it redoes all of the computations again, which is really bad. You clearly don't want to be doing that with your life. So, you know, don't be like me. But of course you can have fun. Like you can really crank up the amplitude of the sine waves. I'm just kind of curious to see what would happen if I did that. You might actually get a Moire pattern in this image, just from cranking up the amplitude of all of the sine waves. And of course, like I said, the interesting thing is you can do, yeah, so this is the same image with all of the amplitudes cranked up. And now you're actually kind of seeing a little bit of the Moire patterns, a little bit, not too much. It's kind of interesting, though. And it's also lost a little bit of the, like, you can put this on the dollar bill effect that it had before. So I was curious about this and I wanted to experiment with it. So the next image that I wound up experimenting with is this image of a beautiful flower. I forget what these are called. I think they start with an R or something like that. And so I kind of wanted to do animations with this. So I decided what I would do is I would export frames from here, and basically what I wanted to do was just take the sine waves and just fluctuate their amplitudes so that, you know, the sine waves start out with, you know, maybe they start out looking like this, and then you slowly but surely flip them. So like the next version maybe is a little is a little dampened, right? Oh, I can't draw to save my life today. The next version's a little like dampened. Wow. Okay, here. This is the axis. I can do this. I can connect the dots. So the next version will be like slightly dampened, and then and more and more dampening until it becomes flat, and then it flips to the other side. So I tried to do that with this image that I have up here. I think I have a video somewhere on my computer of it. Give me 1 second. Let's see. Oh, I shut down the music because the music player. Whoa, what happened? Okay, I need to clear out. So I forgot that like my music player and my video player are the same. So I killed the music to play the video. Give me 1 second. Some stupid technical difficulties, but yeah, here you go. So this is now you're actually kind of seeing like the weird Moire patterns emerge in the image. I kind of like this one. I wish I was able to produce more of these, but at the price of 5 seconds a frame. You know, that's really incredibly time consuming to produce a longer animation. So I wasn't able to quite experiment as much as I would have liked with these ideas. One thing I'm working on is just figuring out the actual equations. And of course I wouldn't be figuring it out. So someone else has probably figured it out already, but figuring out the actual equations for the curves. Yeah, I'll probably make a GIF out of it. Thank you, Ken. So, figuring out the actual equations for the curves, I think could be really nice and really interesting. And so, honestly, this took up so much time. I don't have much more. That I don't have like much more to provide for you guys. One thing I did want to try is that I realized that this cat is a little on the lighter side. It's a coloring. You know, he's an orange cat. So I do have a secret weapon to try again, which is I also have a black cat. So I use this adorable image of my other cat, and I just wanted to see what it would look like. And of course, this is Michael Scott, who wound up in the thumbnail. And I really love seeing those Moire patterns. One of the projects I kind of want to do is, if I can figure out how to predict the Moire pattern that happens as a result of a particular superposition, I would love to be able to actually produce an image inside the Moire pattern. But I think that project will probably take me like... hey there, Brian. How are you? So yeah, so I think one really interesting project, and by the way, if any of you have any tips on how I could potentially make that happen, or if you know about any papers that I could read in order to make that happen, I would love to hear about it. But the idea being that if someone has like a clean derivation of the equations of the actual curves in the de Moire pattern, it would be really interesting, I think, to actually produce like you have an unexpected, right, superposition, and then you put them together, and then a picture of Michael Scott kind of emerges from that. Though that's a really, really hard project, I believe. Also, it feels kind of lonely without the music. I might just put the tunes back on if I could figure out how to do that. Let's see. Or just something. Put my royalty free music back on. I've grown so fond of it. All right, that sounds good. Just louden it a little bit. Very nice. So the other thing that I wanted to do was use my other cat for one of these, just because this little girl is a black cat, so I felt you might be able to see like a more pronounced pattern with this one. So this is what I came up with for this one. Let's see what happens. And yeah, once again, as Los Genta pointed out, I should not be doing these computations afresh every single time, but there you go. I mean, I think that's pretty adorable. I actually think I might hang this up in my house somewhere. And you can see there's these really kind of beautiful de Moire patterns that are appearing in this image. So I don't know, it's just like a neat little hacky way to kind of introduce these patterns into any image. And I kind of like the weird and like trippy kind of effect that it creates. Yeah, I mean, I like it too. So honestly, this is all I had time to prepare. Like, this took me a couple hours, and they were not the smartest hours of my life. I'll say that. So because this code is horrible. It's just absolutely horrible. But if you guys have any ideas for curves to use other than like sine waves or whatever, I'd love to try something. So if you guys have any ideas for how to modify this, I think it would be a lot of fun to potentially attempt to modify this on the fly. And I don't really know what's going to happen. Literally anything could happen. So let me know if you guys have any ideas. I was kind of thinking maybe concentric circles would be interesting. Like concentric circles centered at different locations of different thicknesses. So I could try that and see what happens. Let's try it with the boy. Let's see here. Though, if anyone has, does it need to be lines? What about dots? You can absolutely do this with dots. Though, oh my goodness, I should mention there's an amazing number file video where they don't make images with dots, but hold on, let me see if I can find it so you can watch it. Hold on, de Moire pattern. Yeah, okay, it's called Freaky Dot Patterns. Let me make sure my tab is muted before I dive into this. Yeah, so yeah, one of the ideas I had was doing it with a dot pattern instead of a line pattern. Though I guess my impetus was that I wanted it to look like money first and foremost. So let me put this back up. So if you put two sets of random dots kind of on top of each other and you start to rotate one, you do get interesting patterns. So here, I'm just gonna forward a little bit. So if you rotate it just a little bit, you notice you get concentric circles, which is of course not surprising because there's some central point of rotation for every rotation. in the plane, so that's where the center is. And then if you shrink the points, you would get spirals instead, for example. And there are ways to convert images into sets of points. So the algorithm that I'm thinking of is called a dithering. So these are really old and interesting algorithms that come from a time in the internet when storage was very, very, very expensive. And so people came up with all sorts of neat and amazing ways to kind of compress images. And so you can see here, this is a dithered image. So it looks like whatever statue I don't know what this is. I'm not like a classically trained artist or anything like that. But as you can see, this image is actually just a bunch of dots, right? And these dots, you can convert any image into a set of dots. But this is a really kind of compressed, neat way to store image data, which is kind of interesting, right? I would have to implement some kind of, or like, I don't know if Mathematica has a dithering algorithm that I could use. I guess I could check. But we could absolutely try something where, you take two sets of dots dithered, that are dithered versions of an image, and you just start like rotating them against each other and see what interesting patterns emerge. So to Ken's point, it is a good idea. And I did think about it, but I don't think I'll be able to pull it off I don't think I'd be able to pull it off live without crashing my computer multiple times. Though I don't know, maybe that would be entertaining. I don't really know. So, but if someone else wants to implement that, like that's how I would do it. So there's also another one called, what's the word for it? There's another algorithm to turn images into dots. Let me see if I can find it. Let's see. Okay. The other methodology, or I guess the other name, I don't know if it's an actual methodology for turning artwork into dots, is called stippling. So this is an artist doing stippling, not a computer doing it, I believe. But as you can see, this artwork actually consists of a bunch of like dots, like and that mimics a gradient. Absolutely, it's possible. But let me see. I mean, I guess I'm kind of curious to see what happens. Let me just see if Mathematica has some kind of dithering algorithm, and then we can see. They do. I think I could do it. There's a dithering option, but I'd have to figure out how it's stored in order to change the sizes of the dots. That's so interesting. Color quantize. No, I think what this is doing is it isn't storing the dot locations, it's just producing a new image. So I don't know if it would be possible for me to access the locations of the dots in order to change their sizes, if you see what I mean. So, like I said, it's very doable, it's very possible. You could just crack open the actual algorithm that people use to convert images into sets of dots and just rewrite that algorithm. And then depending how dark the portion of the image is, just use different sizes of dots, and that could produce an interesting effect. Though I think this is beyond my abilities to do live, I'm sorry to say. It is tempting though. It's very tempting. Let's see. I am curious about the concentric circles idea. I might give it a shot, and if this is the end, something to look into later. Absolutely. So, if my computer crashes and this is the end of it, then so be it. But let's see if we can do concentric circles. So, see here. So the table in the original code is for all of my sine curves. Okay, and so this index counts the number of sine curves. I want to keep that around, but change it to circles. So instead of a line, do a circle. Let's see, centered at the origin. Okay, this should be a lot simpler. Let's see. So hold on one second. Let's see. So I'm trying to do circles. Let's see. So this is the internal table. Oh, I see. So this is what I'm getting. Oh, I see. So this whole thing is what I'm getting rid of. And these lines are being replaced with circles. Let's start with these circles with a center at the origin. Yeah, I hope so. Let's see what happens. So let's start with circles. And then let's say they have a radius of k, where k goes from 0 to 3 pi in increments of 0.1. Okay. So now we have concentric circles. Okay. So now what I'm going to try and do is for different thicknesses of circle, I'm going to try and move the center of the circles around. I think that'll create an interesting effect. Okay. So let's see here. What am I doing? And just add a random real. Will that do? That is very trippy. It doesn't look quite as it doesn't look quite as good as I was hoping it would look. It's kind of interesting. Maybe I'll increase the so Langesta says apparently the dollar bill portrait style is done to force digital scanners and printers to exhibit Moire patterns rather than for stylistic reasons. That's so interesting. That's so interesting. I didn't know that. I actually thought it was just like a holdover from the steel engraving that they used to use to make them. But I guess that makes sense that that's the reason why they kept it. That's super cool. Thank you for letting me know. So let's see. I've turned my cat into a horror show. So let me add let me make it a bit bigger. Let's see what happens. Okay, I think one issue is there are just not enough circles. So I'm just gonna do that. Okay, I think the circle idea was a I think the circle idea was a bust. Has some kind. It's kind of interesting. It is a little abstract for me. I think this one's still my absolute favorite. Yeah, I'm gonna try and hang this one up if I can. So yeah, I don't know. If any of you have any ideas, I'm happy to try them. Sorry, the dot one, I just don't have the skills to pull it off right now. But if any of you have any ideas right now, just offset all the circles and overlay, maybe. So you're saying that maybe that is what's happening. Okay. I think what Ken is saying is actually what I wanted to do, but okay, let's. I think I inserted more randomness than I had originally intended to insert. So how about what happens if I do this? Okay, so now the circles are concentric in kind of like a straight line going up. So it has like a ripple effect going upward. That's kind of interesting. What if I do for 2? Interesting. Okay. So, yeah, what I was doing was I was adding a number to a random vector to the center of the. Thank you, ICZESMV. Thank you so much. So what I'm doing is, I guess what I was doing is I was adding a random vector to literally the center of every single circle, which is not so good. But now all the circles that have the same width have the same vector added to them, which looks a bit nicer. I guess I don't want to give up on this idea just yet. Let's see. So what if we actually did random centers? So what I could do is center offsets can be hold on, random, real. How about -2 to 2, and then we'll go 6 is the number that I chose, so 6, 2. Let me make sure this outputs what I want. So this should be a 6x2 vector of random real numbers between -2 and 2. And yeah, it is. Also, the music got a little loud. So I'm gonna skip this song. Okay, so that is what it is. The center offsets are good. So now I'm gonna add the kth center offset to the kth set of circles. Let's see what that does. It does nothing. What did I do? Oh, R. Longer than... Wait, if I ask for like the third element of this, it does work. If I ask for the sixth element of this, it does work. So what am I doing wrong? Oh, center offsets. Should have known. What? What am I doing? Okay. I just wanted to add what? Okay. Go back up. Wait, what is this comma doing here? Oh, I'm multiplying. Ah, okay. Delete that. Okay, I've done something horrible, but I don't know what I've done. And it won't let me undo. Bad signs all around. Delete that. Okay. This is the end of circle. And here I wanted to add. Well, there it is, folks. am I doing? Okay, let's try. Is it only drawing one circle? It is only drawing one circle. Okay, Oh, I know what I did. I deleted the part where I was controlling the radii. So the radii of these circles okay, I'm gonna go back, figure out what it was. So this one still worked. Okay, this one still worked, I think. Okay, now I'm getting rid of the table of signs. Okay, I'm replacing the line with a, yeah, I know, right? Now I'm replacing the line with a circle. The circle has a radius of k, where k goes from 0 to 6 pi in increments of 0.1. The center of the circle is 0, 0, plus a random element, a random vector between -1 and 1. Okay, well, that's something. That's something. At least it's producing, like, things again. Okay, that's kind of neat. So now you can see, actually, it's like it has like a cool like ripple effect going on. Oh man. Yeah, that's not bad. Actually, I think it would be fun to do an animation where all these circles, they come kind of like closer and closer to the center and like snap into place at the end. I'm gonna try that. So I have a parameter called amplitude in my data generation that I can use to have a one parameter family of data. So I think what I'm gonna do is multiply that with my center offsets and range that from 1 to 0. And I'm gonna export all the frames. Oh, the center should be in the middle of the eye. Okay. That's a great idea, Ken. So I think what I'm gonna do is I'm gonna have all the centers slowly converge to the center of the eye. Just need to figure out. Okay, let me just figure out where the center of the eye is. So I'm just gonna do that. Okay, I'm just gonna locate the center of the eye. This is like the worst, stupidest possible way to locate the center of the eye. But the center of the image is here, and the way that I've scaled things is from -5 to 5, right? So I think the eye should be at like -2.5, 1. I'm just gonna try it. And yes, I know there are easier ways to figure this out, but I'm very nervous. Okay, I was close. So let's see. Let's push -2.1, -1.81. Okay, 1.61. Okay, that's good. And then going down a little bit, instead of 1, it should be maybe 0.8. It's interesting. So it kind of looks like there's something up with his eye now, which I don't like. I think I'm going to keep the center at 0, 0. But I'm going to have all of the circles kind of like converge to the center. That's still my master plan. So let's see if we can make it happen. So 0, comma 0. Okay, I like that as a reasonable center. So let's see. Well, I just wanted to produce like an animation. Though if this, like I said, if this crashes my computer, it was nice having you all here. But let's see here. So, okay. I can do, I have the export code good to go. So I'll do 30 frames. Each frame takes maybe 5 seconds to make. Okay, that's not too bad. So, and then I interpolate between 0 and 1. Actually, I want to interpolate between 1 and 0. Let me just verify that what I'm doing makes sense. So for example, if I put in 2, okay. So 2 is actually not bad. Let's, okay. So I hope it's clear kind of what I'm doing, though. I mean, it might not be. I'm just like talking to myself at this point. But the idea that I had was you start with these circles and they're centered. These circle groups are centered kind of like all over the cat. And my idea was to just kind of have them all glom together in the middle. So 30 frame animation, 5 seconds a frame, about 5 seconds a frame. Actually, may as well just check how long it takes to get a frame. That's not bad, actually. It only takes 0.8 seconds to get a frame. So we could actually do like a 60 frame animation. Okay. This is the moment of truth. So let's see. I'm exporting to my documents folder, which I really should not have done, but it's okay. We're in it now. So here's what it's exporting. I'm excited. I actually think it's going to be interesting. Okay. Let's okay. Oh, what'd I do? Oops. I wanted 60 frames. I should have done 60 frames. Now, let's try it one more time. Okay. So, yeah, no, it's going pretty fast. It's like a second a frame. So I should be monitoring the frames, but I just have the folder open. So every time it produces a frame, I can just see it pop up. So I hope that is sufficient. I think it's on like frame 30 or something right now. Okay. Just taking its time. Almost done, I believe. How are you guys today? I'm just chilling, waiting for my computer to export all the frames. And then I guess I may as well warm up Premiere or something. So I can glue the frames together in a nice GIF. Cat. Okay, let's see here. So, okay, my computer just finished exporting. I'm gonna import some data. I don't want you guys to see my file system. So, let's see here. Documents. Man, I like uploaded this to the like cloud folder on my computer. It's super annoying, but all right, let's see how it looks. That's interesting. So I guess this is very similar to, let me go back to the, let me actually export the video. Why don't I copy it on top of itself a couple times so it plays. And I'll reverse the second copy so it has like a looping effect. So speed, duration, reverse speed. Okay. So now it'll like come together and come apart, and then come together and then come apart, which is kind of nifty. So let me just export this video. Export media. Sure, export here. Okay, it should only be a 5 megabyte video, so I'm hoping it exports quickly. Okay, excellent. All right. Let's see how this video looks. So documents. No, don't go to documents. Okay, so this will shut off my music again. Sorry about that, because I'm using the same thing to play music as I am to. Oh my god, come on. Okay, I need to like delete the music playlist and then play the video so that it actually plays. Okay, so there's that. I don't know. Was that worth the effort? I don't really know, but it's cool. You can kind of see the dots coming together. It's basically the same as this Demoire effect. Demoire. Oh my goodness, I'm saying Demoire because of Demoire's theorem in like when you learn complex numbers. So let's see. Just find what I'm talking about. So this one is basically this one here. This one that's going on with the circles, right? But the only difference is there's a cat involved too. So, and I guess there's 6 groups of circles instead of just the 2. So I mean that's kind of neat. It's kind of nifty. Yeah, it's basically this exact effect. More circles, maybe. Sure, I could try more circles. So you want a more kind of like dense plot? All right, let's see. Time to think again. Always a bad idea. So think. Oh, that's easy. I just do that. Wait, what was it before? It was 0.1. So if I go 0.05, that should double the number of circles. Okay, let's see what that looks like. Okay, that's what it looks like with double all of the, like if you double the number of circles in all directions, that's what the image looks like. It took 1 second to export. We could try it. I mean, what else am I doing? So let's try and get it to export 30 frames again. But this time, whatever, I'm just going to run it and hope for the best. It'll export again to my cloud folder, which is annoying, but I don't feel like changing it at the moment. Delete that. All right. So this is with double the number of circles. This one's dedicated to you, Petros. I hope you enjoy it. I think so. I mean, I think it's a pretty good idea. I don't know what's going to happen, though. I think you're probably right. At least I hope you're right. Let's see what happens. Let's see. I can hear all my computer's fans starting to whiz. 21 images have been exported. Oof, my computer is not happy with me right now. So, and this whole time I could have just taken the suggestion. I forgot who it was from. Or the patterns would be more. Yeah, I don't know. I do think you'll get more of something. I don't really know. Yeah, I definitely should have taken, I forget who gave the suggestion, but I should have pre-computed some of this and stored it in memory. And that would have been a smart, that would have been a smart thing to do. But, you know, it's happening. At least these circles are a lot faster than the computer took to compute the sine waves. I think because circles are like a graphics primitive and sine waves are not. So I had to like interpolate to make my own sine waves. Okay. Perfect. It is done. It has exported the frames. Let me erase this and import this. All right. What do you guys think is going to happen? Let's see. I'm going to reverse that. Let's see. Reverse. And all right, let's see what happens. Make this section a little bit bigger. Ooh, that's interesting. That was a good idea, Petros. I kind of like that. That's kind of cool. I don't know. That's neat. Does everyone see the... Do they come through on stream? I don't know, but you can definitely see them. Let me export the video. Maybe that'll... just replace the last video. Okay, let's see here. I need to find where it exported to. It's kind of interesting. It's very, very trippy. But yeah, you can definitely see the Moire patterns. Yeah, it's much less obvious what's causing the patterns. Yeah, it's not bad. It's not bad. You know, I kind of think it wouldn't be the worst idea to just try everything on the Wikipedia page. 'Cause like there's I'm probably not going to have time to do it today, but there's this one, right? Like where you just have a bunch of like lines coming out of a center, right? Hold on, let me turn this video off. So you have like different sets of lines rotating around a center. I mean, that sounds, I feel like that could be interesting. I don't know if I'm going to have time to finish it, but I feel like it's kind of worth trying. Let's see here. So okay, so now, all right, let's see if my brain still works. Always a bad bet. What am I doing? So instead of a set of circles, now you have again a table of lines. The lines start out at the origin and end at the radius, which is now fixed. So I'll just say like 6 cosine, I don't know, x sine x, right? Where, let's see, x goes from 0 to 2 pi, spam call, where x goes from 0 to 2 pi in increments of, let's say, 0.2. Okay, let's try that for now and just see what it looks like. Okay, let me save this before I hit enter. It's not happy with me. Oh, not enough lines. Okay, so let's do 0.02, 10 times more lines. Ooh, it's chugging now. I can feel the heat coming off. Okay, I think this might be this might be the end of the stream. It's still working, so oh my goodness. Yeah, if it took 6 seconds to do the last one, it's probably going to take like a minute or two to do this one. We can wait for a second and see what the output looks like. But there's no way, unless I improve my code, we're going to be able to get like an animation out of this. That looks pretty good, though. The problem with lines is that you really do need to do the thing that they did on Wikipedia, where I forgot the today option. Nice. Yeah, I like where the lines get fatter as you go out and thinner as you go in. That would have been a smart thing to do. So whatever. I think I'm gonna call it. I'm happy with that. We produced some interesting things. I did like Petrus's idea, so thank you for that. I do think this one has a kind of a nifty appearance. I think the lines emerging out of a single point would also work very well. It's just that I need to write better code to make it go faster. But other than that, I want to say I really enjoyed this one. Thank you so much to everyone who showed up. And I had to take some time off. I was getting a little overwhelmed between work and Thanksgiving and whatnot. So I appreciate you all for coming back. And I will be back again on Saturday, streaming more math and math adjacent shenanigans. And thank you to all of you. Peace.